Hey everyone, welcome back again. So in this video we're going to talk about the Cognex CIO Micro. Where do we begin? Well, let's start about the physical characteristics. So on the back, which is going to be the simplest characteristic of them all, it's a DIN rail mounted control block here. So I do believe this is 35 millimeter DIN. Yeah, this is your standard. This is your standard DIN rail mount. You can adjust these how you need them to fit into your DIN cabinet. Obviously, the distance is what it is. Not a huge fan of how big these things are. They take up a lot of cabinet space, and they're kind of bulky, clunky, and huge. But when you need a lot of inputs and a lot of I/O, these definitely will save you in the long run. The other nice thing about them too is if you need power over Ethernet, these control your power over Ethernet versus having a camera that has to have a separate PoE injector somewhere along the way. Alright, so we'll talk about some of our major fittings here. Obviously you have your ground screw right here. You have an RS-232 cable, which I'll be up front with you. Anybody who's using an RS-232 cable in today's world, especially in a camera setting, leave a note in the comments, because I'd like to meet you or know about you, because honestly, I don't know anybody that's still using an RS-232 connection, especially in a camera world. Most of us are all going to use a LAN port or your Ethernet port. So our two RJ45 connectors, LAN, power over Ethernet injector. The PoE injector, pay attention to this. This is important right here, okay? The PoE injector is for the camera connection. If you don't have a camera that has a PoE connection, don't use this, because this is just a waste of time and money, okay? If your camera can run off of power over Ether, use this controller. Now, I think these are kind of on that more obsolete end. They still sell them, they still make them, but they're more on the obsolete end, so active, mature, if you will. So these are a little bit harder to come by. But in all reality, do you really still need the power over Ethernet anymore? No, not really. Not off of these CIO Micros anymore, but you still need the power over Ether because that camera still runs off of power over Ether. Now, there are some other options that we have, and in another video we'll talk about the HMI that's associated with Cognex and how it also has a PoE injector as well. You can also just buy a switch that has PoE injectors and then use the switch to power off all of your stuff. Anyway, back to where I was going with this is PoE has to go to the camera. The LAN goes to your network. Just keep it plain and simple that way, okay? Because if you connect your computer into this PoE, if you have a new enough computer and it's intelligent enough, it's going to see the PoE injection and it's just going to shut it down right there. Otherwise, on an older system, you'd fried the port. You'd fried the port, you'd fried the motherboard, you're done. The computer will still work, but that port's shot. You'll never use it again. But on certain switches and stuff, it also has a recognition for the PoE, so if this got into a switch somehow, more than likely, you might have fried the port, but more than likely the switch just knew not to use that PoE and just shut it down right there and left it. With that being said, then you also have an I/O port here. This I/O port is actually going to the camera. So this DB, I want to say that's like a 20... I think it's like a 15 pin actually. This cable connection here of this I/O is going to the camera. It's giving you the additional inputs and outputs for the particular controller or the camera itself. So this one here, I've seen this used a lot in the industry. We still use this because of all the other I/O that's used on the CIO Micro. Now, we talked about in other videos about how there's other controllers for lighting and loads like that. The CIO Micro, the benefit of this was we wanted to put the lights in with the controller itself. So when the camera needed to be triggered, it also wanted to trigger the lighting load itself. So, with that being said, you had 24 volts DC power coming into the controller. Then you have a trigger. So this trigger itself is actually what is triggering the camera. So that is the power to trigger the camera to open the shutter, if you will, and then close and allow the shutter to close after that. Okay. You also have a high-speed output for the two, so when the trigger comes, the high-speed output can go on whatever your configuration is inside of your camera. We can talk about those configurations in another video where we'll cover some of that. High-speed common, so again, these are kind of like a relay output in a sense, so you gotta have a common for that. Now you have your inputs. So you have, looks like 8 inputs plus another common. So again, just like a PLC, think about it that way. Think about this controller almost as a sense as a PLC, but the camera itself is what's controlling all of this I/O and everything of this board here. Okay. then you have your outputs as well. And so say you have an output 0 and 1 or good, no good, you have a light that simply flashes one way or another, and then output 2 stops the production line so that they can clear the fault, whatever that might be. So that's what all of this is doing. Huge advantage in the world of Cognex. However, in the world that we're moving towards, where everything is all network driven and everything, we're starting to see more of a decline in these CIO micros, and it's because of we can use just the simple, we can use the triggers and the high-speed output off of the camera directly. We don't even need this I/O. We've got 5 terminals that we're using. So we're using 2 for power, 1 for trigger, 1 for input, 1 for output, and that's it. That's all we need. We need those 5, and that's it for the camera. And then the camera sends back any other information via the LAN cable back to the PLC, so the PLC can then process all that information and tell everybody what to do. So these are starting to go by the wayside because of those advanced features. We're also seeing in the latency and Ethernet starting to decline more and more every day too. Hence why we're starting to see with Allen Bradley's SIP safety moving from just a hardwired discrete system to a SIP safety with Ethernet. So by seeing those advantages and the decrease in the latency, we're starting to again see the decline in these particular controllers in favor of network cables and network systems. However, these have their advantage, and they still have their advantage in the world today, and they had their advantage back in their heyday too. So don't totally leave these ones out thinking that they're absolutely junk and worthless. They have their place, but do they have their place in your application? That's the question you have to ask yourself. So, thank you all for watching, and stay tuned for additional videos.